Randomness is a theory used in social sciences and mathematics to refer to factors of chance that occur in such a way that the individual occurrences in a sequence of events or outcomes do not display a connection in their frequency to each other. Events are independent of each other, and thus the occurrence of one event is not in any systemic way related to the happening of other events in the sequence. It is assumed that randomness is an attribute of a series of events, is the product of multiple minor causes, generating small effects as an outcome, resulting in no systematic predictability for a particular event in the series. The effect of several minor factors, some of which cancel one another, is the independence of each case from the other. It's noteworthy that causation activity in the world of events and interactions is not disputed. Rather, the causal backdrop to a series of random events is defined as a multiplicity of small effects, some of which are almost infinitesimal in size, with some results in abandoning or keeping in part other bases. An effect is a sequence of separately occurring events to one another. In common terms, the word chance is used to refer to this state where events are produced independently of each other. Randomness and its distribution. A particular interest to social scientists is the quantifiable observation that when a sequence of events occurs in large numbers, certain random distributions pursue fairly predictable patterns. Specific results or instances cannot be predicted with absolute certainty, but it can be shown that a random pattern follows a wide configuration in such a way that a wider probability or likelihood of occurrence can be attributed to larger areas in the distribution of random events. Instances involve numerous known or empirical distributions of random events that adopt the bilateral symmetrical distribution, generating a curve called the normal curve. Another similar known probability distribution is the binomial distribution, where only two possible scenarios will occur in a series of random events, such as throwing an unweighted coin a large or even an infinite number of times. The binomial distribution computes the usual probability curve with a large sequence of discrete, independent tests of two possible outcomes. Yet another known distribution of random events is the chi-square distribution, where the x2 statistic is determined on several randomly drawn samples if the samples themselves are chosen from a wider universe of randomly distributed frequencies for a variety of observations. Randomness and Statistics. The area of statistics as applied in social science research can be split into two broad branches: descriptive statistics and inferential statistics. The object of the first division, descriptive statistics, is the summary of the data. Measures of central tendencies, such as means, medians, and mode, usually summarize data. Data variation, or dispersion, may be summed up with variance measurements and standard deviations. When two or more variables are compared, a researcher can seek association using correlation measures. The second, wider statistical category is inferential statistics. It is the category used to describe randomness and the use of defined random distributions to analyze the empirical distributions for deviations from randomness. Departures from randomness in the latter scenario can be mathematically measured, which can be of great use in the evaluation of causation. The quest for causation starts with the confirmation of the correlation, or association, between observations and the observer. Departures from randomness are of great importance, as the initial indication of an association or correlation pattern is given. This second broad field of inferential statistics is itself divided into two large segments.